So I guess now it's time for PLX. So we can go on with our agenda. So Michelle, if you want to share your screen and start with your presentation, the floor is yours.
Sure.
He's coming. It's not presentation mode yet, but yeah, there you go. There you go. You can start.
Thank you. Hey, so I'm Michelle Hyers. I'm the Director of Engineering at PLX. So I'm just going to talk a little bit first about what we do. So the manipulation of light. So I think there's a lot of talks so far today presenting basically how to get the laser beam for surface structuring. So this is a really good application of what we do. So anything regarding beam delivery and at really high precision levels, so we're talking about sub-arc second, we do a lot of applications for us in targeting, bore sighting, beam folding, steering, any of these laser systems, interferometry, so some of those beams you guys were using for interference to put down those patterns. And we have all different versions. So we're really the pioneers of what we call this retroreflector, these invariant optical systems, to basically have the path here on the bottom left-hand side, coming back with these small deviations. And we have all these other systems that we've developed, lateral transfer, hollow retroreflectors, periscopes. But really with the heart of what we do on the bottom right is all these different types of custom OEM applications. So whatever system you guys have, we would provide the solutions that would work for you. So in our business model, we really work at the level of assemblies all the way up to system integration. So if you guys have this custom application trying to develop a new laser system for this the surfacing, we can we really like if you kind of come in at the beginning level, because it can really help us really integrate our technology kind of for your maximum benefit, all the way up to kind of the housing system level. And what we're looking for in Epic here and just in general is to really work with our technology and find these key partners that can utilize our technology and work with them to really develop different applications. What we do in-house is engineering, so utilizing our technology and our expertise to do these high precision optical assemblies and solutions. Analysis of those systems, so we can do FEA, we do a lot of environmental testing, thermal vibration shock, and we do the fabrication. We have the optical shop, assembly, coding, clean room, everything you need to really bring that solution and make it. That's our proprietary know-how. So in regards to this topic, if we can look at some of these sorts of systems. So for surface structuring, you want to basically deliver the beam, and you want to have some, different benefits of the system. So some of the things we could use that are kind of our main core solutions are all these invariant systems. And I'm going to talk a little bit about the last one, the MOST, at kind of the end. But there's pentamirrors, there's these, the LTHR, LTHP that I talked about before. And the MOST is kind of shown on the bottom right. That is really one of our main core technologies, is monolithic structure. Again, invariant, all these being very robust in terms of vibration and thermal concerns. So with this solution, we can really provide a bunch of different benefits for these laser systems. We can use multiple laser systems. So if you want to switch different beams or use multiple beams, the benefit of the MOST is that it's pre-aligned. So everything in this kind of sandwich structure on the bottom right can basically be put into the system and is extremely accurate. The overall beam deviation goes to the sub-arc second level. So you can basically put this kind of plug and play optic. You don't have to worry about adjusting everything. And it's very highly stable in thermal and vibration. So if you're worried about, doing high scan speeds, you have high power heat issues, vibration issues, these sort of products are used, a lot of our applications are actually military defense. So these are battlefields kind of condition ready optics. So an example to look at, just to see what something like our optics and our solutions can do in this industry. So for instance, we can look at something example like an articulated arm to deliver the optical beam for a laser. So in this system, maybe you have two laser beams that you're going to either split between, or it could be an interferometry kind of setup. where you can basically have different optics. This is just one example. We have a pentamer, but this can be all different types of optics in that first section. And then we can use basically some of our LTHP, basically stacked in this kind of articulating arm setup. And we can do multiple axes. But the benefit of this is this invariant system. Because of this, if there's any kind of slight movement or deviation, there's not these alignment issues that may plague your system. So you should be able to get a much higher accuracy at basically at the beam delivery site. With this, you can move the beam around. You're not moving the workpiece. So you can potentially make a much more compact laser system. If you're basically doing this instead of something like a scan lens system, you can have longer, that you're not necessarily required to have the long working distance. So the system could be much more powerful and compact. And it's not limited as much by power handling issues like fiber systems. So a lot of its benefit too is we can deliver high powered lasers with this. So this just shows you on the left kind of the physical layout. I'm going to play this little animation here on the right. Hopefully you guys can see it. So it just shows basically, you know, taking a system, combining some of our high precision assemblies and basically be having a very robust system for laser scanning on the surface. And we can do multiple configurations. This is just to kind of give you an idea of, you know, one possible version. So with this system, there's a lot of benefits that PLX can offer using that technology. So because they're front surface mirrors, you have wavelength independence. So if you want a quick switch amongst different lasers, different laser types, wavelengths, that's perfect. Beam diameter. Usually a lot of our systems are around 1 inch to 2 inch diameter, but we can really customize. We've done a lot of different scales. So you can get a large power density and low divergence. The structural design, our elements are enclosed and like I said, pre-aligned. So you get this accuracy. The beam deviation I talked about and variancy is really important to have that performance. And that also comes with a lot of stability. So a lot of our systems, and I'll talk about in a second, the most is athermal designs with CT match materials. So anything thermal and a vibration or shock is not going to be an issue in our sorts of systems. So I just want to, so I talked about the MOST briefly. I just want to show just a little quick video so you can kind of see exactly what I'm talking about. Oops. Go through. Play.
Maybe it's on the other screen, if you have a second screen.
No, it's not doing it. Okay. Let me just show you this one. So basically, if you take kind of a conventional optical bench setup here, you can kind of really combine these elements. So if you think about this in terms of the surface structuring system, you know, you might have all these different elements that are moving and basically being adjusted. So there's a lot more kind of room for error and inaccuracies, especially if your system is scanning really fast and there's vibration and other factors going on. So this really takes those elements out of play and really puts it into this kind of, if you look at this kind of, we call it a sandwich kind of structure. And this is extremely customizable. So we've done all different types of, this happens to be, you know, example is glass, but we can do other materials, metals, ceramics. We can do different elements. We can do freeform optics. This is just, could be mirrors, beam splitters, anything, lenses, anything you can configure can be put into this technology. And with this, because it's in this one structure, this is very robust. So you might think it's glass, it might not be as strong, but it's completely not the case. So these things have been tested and used in very harsh conditions, vibration shock, and large thermal ranges. So these, you know, might be in something that goes shot up into space or like I said, or for military applications. So I think in this industry, it would be really a great fit. And all of these different elements of PLX, the monolithic, the retroreflectors, we can do a lot of lightweight optics and variant optics really come into the system integration level. And that's where you can provide the most benefit for you guys developing these sorts of systems. Just to give you just a quick range, you know, of what we can do scale-wise, wavelength ranges, beam deviation, and just sizing. So if you're talking about, you know, depending on the scale of your system, you know, we've made things very, very small down to, let's say, 2 millimeters. We've also done some opto MEMS as well in this industry. So, and then things up to offset. So we talked about those spacing of the beams. We can go up to, you know, basically meters as well. And environmental, I mentioned the shock, I mentioned the temperature variation. These are just some of the numbers, so you can see what we're talking about in terms of shock, vibration, and in temperature range. Okay. And then this is to show you just all the different versions of some of the things that we can do.
Thank you very much, Michelle. Thanks a lot for your contribution. And I think definitely it's very interesting for this community that the high power is actually your systems can stand the high power. You also have put a lot of weight on the let's say harsh environment application. Maybe this is not for the laser structuring people, but I know, for example, Dietmar is also dealing with these devices that can be brought in of course, different environments. So I guess you give a large, nice overview for everything that can be needed also for other projects, side projects of this audience. So it's very good. So are there questions for Michelle? So if it's not the case, someone? No. Okay, I guess, Michelle, you have also the possibility to have a lot of contacts here. So you heard already. Do you want to maybe comment on some collaboration you would like to have? You thought about some speaker before you?
I think there's, I guess, several that basically, if you're developing laser systems, I think we have a lot of applications for you. And we're very always interested in to partner with you and really come up with new kind of merging technologies together. So just reach out to me and we will figure out a system for you. There's nothing we say no to try to develop using our technology. There's so many applications.